Welcome to YO Today. I'm Paul Pepis, Director of the Oregon Humanities Center. My guest today is Ramon Alvarado, Assistant Professor of Philosophy and an affiliate of the University of Oregon's Data Science Initiative. Alvarado's work focuses on the philosophy of computation, data ethics, and the epistemology of science. He has published work on ethical issues relating to big data, machine learning, and artificial intelligence. Thanks, Ramon, for coming on the show.
Oh, thank you for having me.
And welcome to the University of Oregon.
Thank you.
So as I've just mentioned, you have expertise in the philosophy of computation, data ethics, and the epistemology of science. Let's take those foci one at a time.
Yeah.
So how do you understand the philosophy of computation? What is that?
So philosophy of computation is actually a very broad field, right? And in it, we ask all kinds of questions relating to the nature of computation. What is a computer? What is an algorithm? Those would be kind of metaphysical questions about the nature of the object that we're investigating, right? But we also ask things in epistemology of computation, which are related to how the introduction of computational methods have affected inquiry or our methods of knowing, which is more related to the way we do science and stuff like that. But you know, the differences between an analog and a digital computer, the differences between a discrete computation versus a continuous computation. Those are the kinds of questions that we ask in philosophy of computation generally. I more particularly focus on philosophy of computer simulations.
Say a little bit more about that.
So we use a lot of computer simulations in science, and the tradition in philosophy for the past 20 years has been to treat them either as extension of formal methods like logic, mathematics, or models, or as empirical experiments. And there's been a battle or a debate for 20 years as to which one best captures the nature of computer simulations. And once we decide which one best captures it, what does it say about how we can trust them, when should we use them, and what kind of import they bring into scientific inquiry.
Do you have a position on that debate?
Yes, definitely. For me, they're neither. They're actually instruments. And so if you look at science of course has theoretical elements like models, equations, and things like that. It also has empirical practices like experiments. But often neglected are the instruments with which we run the models or carry out the experiments, right? So if you look at a telescope, it's not an experiment. It's definitely not a model. It's the thing with which we can either inquire about the veracity of our models and or run our experiments that have already been designed. And I think that simulations are similarly like that. They're actually artifacts, and they're tangible artifacts that require both software and hardware architecture, and we can point at them and see this is the simulation. And so I think that that's a brand new narrative that I'm trying to push into the debate, that whereas we can learn a lot from seeing them and seeing the formal elements of them as very important and of course crucial to the way they function, we can definitely learn a lot from seeing them as from the point of view of an experimental practice, because they do bring new knowledge that was not there with the other elements of inquiry. But we would learn even more about when we should deploy them, how we should trust them if we treat them as we treat other instruments.
Fascinating, fascinating. So the next area of your area of expertise is data ethics.
Yes.
So what's that?
Yeah.
And why is that important?
Right now, data ethics is in a moment where it's still being defined. We don't know exactly what it is. What we do know is that there's a growing concern with the way we've been using the vast amounts of data. And the crucial problem that we're dealing with in the last 50 years was that the mathematical methods and models used to analyze data are now being used not just for scientific purposes regarding physics and or ecology and or biology, but rather human behavior. And so that's the reason why you see it in the news all the time. It's not because they're new, they're actually been around for 60 years or so, but because we've been more and more deploying those same methods in the realms of human behavior. And so psychological issues, sociological issues, and of course, even just personal issues. We use data for all of those things. And so the ethics approach is, hey, shouldn't we wondering about the implications on how we treat each other? What obligations do we have to one another? What are corporations supposed to do when they have this power of having so much information on us? Now, so data ethics, generally construed, it's also very broad, right? Because you might be talking about bias in data sets and data algorithms and things like that, but you may also be wondering about what are the social and ethical responsibilities of the corporations. So it's a mixture of all kinds of questions regarding business practices, but also personal behavior and I guess, you know, the future of humanity almost, right? Because it seems that at any given, if you look at where we're going now, it's not like we're doing less of it. We're actually deploying these methods in broader aspects of our life. So it used to be the case that our online behavior was tracked in our desktop, right? It's like, okay, but every time you're out of your away from your desktop, you have your own, you know, doings and nobody knows about them. Now we have, of course, cell phones, and they, you know, there's all kinds of about 200 sensors in your phone that are sending, you know, data points every 2 through 3 seconds. But then you also have these other external devices that are tracking us even when we're not carrying them. And now we even have the Internet of Things, in which even your toaster is going to be sending information about, you know, how long you toast your bread for and things like that.
So it seems to me it's profoundly urgent.
Yes, but it's also very unclear what it is as of now.
Yes, right.
Yeah.
The technology has outpaced the ethics. I mean, we're sort of catching up with the technology.
So we're trying to see whether our old ethical theories actually help us with any of these. We're trying to see how adequate they are to help us investigate this. Some of us are actually trying to attempting to define data ethics in a narrower sense. So, for example, business ethics arose because somebody, specifically Richard DeGeorge in the 70s, said, you know what, there's something very particular about business practices that have specific and particular implications in ethics. Maybe we should have a discipline called business ethics, because it's not like medical ethics and it's not like ethics in general, right? And so what some of us are trying to do right now is, what is so specific about data science methodologies such as machine learning, big data analytics, and artificial intelligence that makes it a branch onto itself in the ethics umbrella, right? And so right now, for example, a lot of us are talking about how data ethics can be used in wrong ways in the wrong context. So some of us worry that data science, right?
Data science,
The data science methods are being used to assess the probability that you will commit a crime or that you will incur in committing the same crime again. And then based on the results of that, you will be getting a parole or not, right? So some of us worry, like, look, the context in which the methods are being used is already ethically problematic. I mean, it's justice, is affecting people's lives and stuff like that. But what if you use the hammer on the same setting? I mean, would the hammer be ethically problematic? No, it's mainly the setting that is ethically problematic. And so hopefully I didn't go too far on this analogy, but the idea is, like, it's not just the setting in which these methods are deployed. We should find out what about the methods themselves is problematic, regardless of the setting in which they are deployed, right? And of course, even though it's important to see that they're not deployed in the wrong places, we should also see just by themselves as a formal methodology of analysis, by themselves as, you know, automated statistics, do they have any ethical dimension to them?
That's completely fascinating. So you mentioned big data, machine learning, and artificial intelligence.
Yeah.
Okay, so let's talk about each of those a little bit.
Yeah.
So what's big data?
Yeah.
What's big about big data?
Yeah, so it's being defined in many ways. Sometimes it has to do with the speed with which it is gathered, with the vastness of the data points that we have, and or the diversity of the data points and the kinds of information that we're getting from those points. And originally, it was defined in 1995 by some NASA engineers as the big data problem, which was the following: this fraction of information regarding galaxy formation, and it's just a fraction, doesn't even fit in my desktop.
Right.
That was the problem. And they actually wrote, I forget the name of the authors, but they wrote the paper on the big data problem.
Just too big. Too big for the computers we
But
have.
it was just big in size, and it was big for the desktops of 1995, right, in NASA. So now, of course, so originally it just meant it's huge amounts of data. Now it means something else. It means, the data is complex, the data is changing, because a lot of the times it's actually real-time data. So you're receiving every 2 to 3 seconds updates on the sensors that you're tracking. And so it has to do with, when we say big data now, it means complex analytical methods applied to complex data sets. And by complex, I just mean that they can change, they're diverse, and they're multiple. There's many different points, but those points are not are heterogeneous rather than homogeneous. They're not just one kind of information. You can be getting visual information, you can be getting speed information, you can be getting audio information, completely different kinds of information, lots of them on each sensor, and then you need to use methods. Those methods of analysis are called big data.
Okay.
Yes.
So that's the first one. The second one is machine learning.
Yeah. So machine learning is a method of automating programming that can analyze, so automating code to analyze data, right? And so you have algorithms that, let's say you want to find something specific in a data set, you can just program it to look for what you're looking for, right? With machine learning, what you do is that you actually feed data to an algorithm and make it so that the algorithm can better identify patterns on that data that you're giving it, right? Sometimes machine learning methods are supervised, which means you kind of know what you're looking for, and then you just make sure that your algorithm is getting the right instances of what you're looking for. Sometimes they're unsupervised, and that just means you have a lot of data. You don't know any patterns. You feed it to your analytical algorithm, and hopefully you'll get some strong enough correlations that will later guide your inquiry, right? But so just to narrow it down, machine learning is a method by which you optimize your analytic algorithms with the input of data.
And that's from the perspective of the inputter of the data or the analyst of the data.
Yeah, that's from the perspective of the practitioner.
Yeah. So because I think about this from the perspective of the consumer.
Yeah.
So I'm thinking of things like Spotify.
Yeah.
So I keep listening to this music, and it starts telling me, oh, you should listen to this music.
Yeah.
Is that a kind of machine learning?
Yeah, definitely. So the machine is actually learning, from your preferred behavior, and it's kind of saying, it's like, oh, you like Steely Dan? Here's another. Here are Doobie Brothers, right? And if you like the Doobie Brothers, you might like this. But it's if you remember, when you started using Spotify, it was actually terrible. It was actually not that, well, even nowadays, it's still some, like, especially if you speak or listen to music in other languages, it's terrible, right? Just because you listen to a rock band in Spanish, then it gives you rancheras and mariachi, and you're like, wait, just because it's in Spanish, right? So all that. So, but give it a couple of months and keep listening to that, and it will narrow it down. And so from the perspective of the user, it means a optimized experience of a system that learns your possible future states of mind, right? And can learn from the data that you're giving it to better serve your needs. And that's, of course, almost like a selling pitch, right?
Right.
Yeah.
Yeah, so that's like consumer think.
Yeah.
Right? It's like better capitalism.
Definitely.
Yeah.
I mean, it is to a certain extent a convenience, right? I discovered a lot of music like that. You discover films like that. And what is ultimately looking at, and this is the scary part, what it's ultimately looking at is to serve you the best, but it's also by predicting you the best. And so it's a bit scary that we can be predictable like that, because we usually think of humans as being, you know, oh, we're messy. If I don't know what I'm about to do, how can the machine do? No, but...
And that it's not just the machine, it's the corporation that owns the machine that knows all this stuff about me.
Yes, so a lot of the problems with the corporations that give you features like that is that they're not only using it for their own purposes, but there's actually data exchanges. Just like trading exchanges, like the Wall Street, right? Now there's data exchanges in which people just throw out information out there. Somebody buys it for pennies, cleans it up, analyzes it so that it's in better labeled packages, sells it back again for 2 or 3 pennies more, and then, you know, so an exchange begins. And so corporations like like Spotify, Facebook, don't just use the data and the analytic methods for themselves, but they use it as a, you know, as a resource, and then they sell it to third parties.
So I assume that the kind of ethics work that you do has as one of its components this question of what are the implications of the monetizing of data?
Yes, to a certain extent, we're wondering what is new of this resource, right? And so people like Shoshana Zuboff has a beautiful take on it from an economist perspective, which says, look, the way capitalism works is that you identify a resource out there in the wild and you bring it into the market, right? And once you bring it into the market, then you monetize it and you make profits out of this. So what happened in the late 90s and early 2000s was that somebody realized, like, wait, we have all these extra data just laying there. We don't even know how to erase it, where to put it. And it turns out that if you use predictable models, it's really accurate. So maybe we can make some money with it. And so what that data was, that was human behavior data, right? Online human behavior data. And so for her, it was the moment in which surveillance capitalism emerged. And that was, look, we have data about human behavior. We can survey people's behavior. Let's bring that into the market. So that's definitely a worry for some of us because of the incentive of producing and extracting more data from us. But to tell you the truth, right now my research is a bit sort of removed from that. I'm still going back and saying, like, let's think more carefully about it. What exactly do we mean with data ethics, right? And then what exactly do we mean by privacy? Because even notions such as privacy are not fully fleshed out in philosophy, right? And even in the media. When we say I have the right to privacy, I'm not really sure what I'm referring to, right? And my research as an academic and of course as a philosopher, which might be annoying for a lot of people, is like, before you say that, can you clarify what you mean by privacy? Can you clarify what you mean by data ethics, right? And then let's see. And so I am taking it slow in that sense, right? And I want people to acknowledge that slowness is good at this point, right? I know that the industry is moving faster than we are, but our job is to be careful, and our job is to say things with precision, hopefully, right? And that cannot be done fast enough, or just it cannot be rushed. And so, yes, I'm definitely worrying that. Yes, I'm working on that. But let's say for my students that are coming to my data ethics seminar or my Internet Society in Philosophy, I want to push back and say, it's like, look, before we say what the journalists are saying, let's do a little bit of philosophy and see whether those terms actually track anything, right? So that's a yes and no answer.
Yes, I understand. Yes, you're a philosopher. So let's do a little bit of slow thinking about artificial intelligence.
Yes.
So tell me about that.
So I hope I'm going to speak of it in relation to how I want to teach it to my students, right? And one of the ways I've been envisioning is to make sure that my students understand how boring artificial intelligence can be. First,
great. I see the commercials.
Yeah, they're great. And
with Common, he says it's great.
Yeah. But I want to. So, you know, we've been worrying about the rise of an artificial mind, the rise of an artificial consciousness, about the robots coming for us, and that's fine, you know, for entertainment. But I want to sort of pull back the curtain and say, any of those things are actually just applications of something more boring, which is automated statistics for optimization of services somewhere in a server in a warehouse, just humming along, right? So if somebody's going to get to you, if somebody's after us, let's say in Terminator style, it's not a robot, it's an equation, right? And so then now let's talk about what can an equation do to us? What can an automated statistical method do to us? Turns out it can do a lot, right? I mean, if you think about artificial intelligence as being one of the many ways in which you can program a computer to learn from data and then use what it learns on decision-making procedures, right? You can see that that kind of technology, that kind of assessment, that kind of methodology has been being used for years by the insurance companies, by the credit companies. And so if artificial intelligence is going to take over, it already did about 30 years ago, right? So going back again, I just want to make sure. So when I talk to my students, I just try to first bring them down here. Look, this is automated statistical analysis in vast amounts of data that, you know, machine learning benefits from, and then optimizing decision-making procedures benefit from. The last part, the decision-making procedures, that's artificial intelligence. But of course, before that, you have machine learning, and before that, you have big data, and before that, you have data, right? And statistics, of course, at its foundation. And so if you ask me, if you were a student and you ask me what is artificial intelligence, that's exactly what I would tell you. There's, you know, it has a lot more to do with statistics than it has to do with robots. Yeah.
Fascinating. So you've mentioned your students a number of times, and you talked about you mentioned two of your classes. So tell me about one of those classes.
Well, you know, I'll tell you about one class that I taught last term that I really enjoyed. It was Ethics of Technology, and it was beautiful to use actually an old book from 1970s called Autonomous Technology, because I think it was a surprise to my students. It's like, wait, I thought we were going to talk about Facebook and we were going to talk about Spotify, which we did, but we started with a book on the relationship of humans towards automatic technology, dating back to the Romans, right? Dating back to the automatons that we built in the 1700s and the 1800s, right? And exploring the politics of fear and the relationship of fear that we've had with these kinds of technology. And so when you are talking about an autonomous vehicle, now in 2019 or 2020, right? There's a lot of resemblance with the way we talk about our fear with autonomous vehicles that Google is putting together and Tesla's putting together with the way we used to talk about all kinds of other technologies centuries back, right? And so I was really happy to be able to make that bridge and tell my students, look, these issues and these questions have been around for a while. And if we can identify what's so important and fundamental about them, then we can analyze our current context in better ways. And so I think for me, the triumph there was bringing forth the humanities in a digital era and telling them what a thorough analysis this 1974 book, especially from a historical perspective and a political perspective, can give us in a context such as now, right? Instead of just throwing out the technology and talking about the marvels of technology. That was a really interesting moment, because I think that's our job as a philosophers, to make sure that in these conversations about technology, first of all, technology is not new.
Yep.
You know, I mean, it's been going on since we invented the first tools, right? And second, the questions about technology are not new, right? And third, the centrality of the humanities to understand the context and the importance of these novel introductions, you know, these novel devices.
Yeah, so this, I mean, in some ways, you know, when I saw that you were hired as a philosopher of computation, I thought, like a lot of humanists think, wait a minute, that's a contradiction in terms, right? I mean, philosophy is a humanities, and computation is a natural science. At our university, it's a natural science.
Okay.
But you've made a really great case. I mean, I'm always looking for cases about why the humanities matters now. Because there's so many things happening around us in our society. So the numbers of humanities majors are going down. People are saying humanities degrees don't give you jobs, et cetera, et cetera. But you're now making a really interesting case for the benefit in terms of what, you know, what we think is only happening now.
Yeah, I mean, if you allow me, I want to give you even a better story, which is like, so logicians and mathematicians and, you know, early philosophers of the 1800s, of the late 1800s, were actually trying to find out ways in which they could see whether an argument was decidable or not, whether an argument was easily seen as having a conclusion, yes or no, right? And in their efforts, they were doing a lot of formal logic and formal mathematics. Those efforts of trying to see whether arguments could be decided ahead of time, whether they were valid or not, was what informed later in the 20th century, like, you know, in like 1910s, 1920s, the mathematical and abstract notions that then led to the creation of the first computer, right? So Alan Turing was studying a lot of logic, right? But that logic came from Russell. Russell was a philosopher, right? And so I could make an even bigger case, at least from the philosophy perspective, of the importance of the humanities, even in computational technology, period, right? Philosophers were there before the computers, putting the foundations of what is computable and what is not, before Alan Turing formulated this abstract notion of universal machine.
Okay, well, Ramon, on that excellent note, we're out of time. I want to thank you so much for taking the time to talk to us. It was fascinating. Your work is incredible. We're very fortunate to have you here at the University.
Thank you very much. I really appreciate it.
You're
It was a pleasure.
I've been speaking with Ramon Alvarado, Assistant Professor of Philosophy and affiliate of the University of Oregon's Data Science Initiative. Thanks so much for watching.